Today we are going to learn about mastering KDE plots with Seaborn. In this video, you'll acquire skills to create, interpret, and customize KDE plots for effective data analysis. Welcome to our introduction to kernel density estimate plots. KDE plots are a powerful tool in data visualization, often used to represent the probability density function of a continuous random variable. Unlike histograms that provide a rough estimation of distribution, KDE plots offer a smoothed and more interpretable curve. Today, we'll explore how these plots can help you identify patterns and trends within your data, making them indispensable in your data analysis toolkit. To get started with creating KDE plots, we first need to set up Seaborn, a Python library built on top of matplotlib, designed for making statistical graphics easier to create. Begin by installing Seaborn using pip install Seaborn. Next, import the necessary libraries in your Python script, import Seaborn as SNS and import matplotlib.pyplot as PLT. You'll also want to import pandas for data manipulation. Import pandas as PD. For this tutorial, we'll use the tips dataset from Seaborn's built-in library. Load it with tips equals sns.load_dataset tips. This dataset includes information about restaurant bills and tips, perfect for practicing KDE plots. Take a moment to inspect the data structure using tips.head. Understanding your data is crucial before you start plotting.
With our data loaded, let's dive into creating a basic KDE plot. Start by calling the KDE plot function, sns.kdplot data equals tips, x equals total underscore bill. This command plots the density of the total underscore bill column. The KDE plot will show a smooth curve representing the distribution of total bill amounts in the dataset. By default, Seaborn handles many parameters automatically, but knowing how to interpret the plot is essential. The peaks in the KDE plot represent the most common values, while the width of the plot indicates the spread of the data. Unlike histograms, KDE plots provide a continuous estimation, making them ideal for identifying subtle patterns in data.
One of the most crucial aspects of KDE plots is the bandwidth parameter, which controls the smoothness of the plot. Bandwidth is essentially the width of the kernel used in the estimation process. A small bandwidth may result in an overfitted plot with too much noise, while a large bandwidth might oversmooth the data, hiding important patterns. Adjust the bandwidth in Seaborn using the bw_adjust parameter, sns.kdplot data equals tips, x equals total underscore bill, bw_adjust equals 0.5. This setting decreases the default bandwidth, producing a more jagged plot. Experiment with different values to see how the plot changes. Generally, smaller datasets require larger bandwidths to smooth out the noise, while larger datasets can tolerate smaller bandwidths, offering more detail.
A powerful feature of KDE plots is the ability to visualize multiple distributions within a single plot. This is particularly useful for comparing different groups. In Seaborn, you can achieve this by using the hue parameter. For example, to visualize the distribution of total bills by day, use sns.kdplot data equals tips, x equals total underscore bill, hue equals day. This command plots separate KDE curves for each day, allowing you to compare the distributions at a glance. Notice how the plot differentiates each group with different colors, making it easier to identify trends and differences across categories. This visual comparison is invaluable for understanding variations between groups in your data. Overlaying KDE plots with histograms adds depth to your data visualization, combining the smoothness of KDE with the concrete distribution view of histograms. To create an overlay, use the sns.hisplot data equals tips, x equals total underscore bill, KDE equals true function. This command plots a histogram with a KDE curve on top, giving you the best of both worlds. The histogram provides a clear view of data frequency, while the KDE curve shows the overall distribution trend. Consider using the shade equals true parameter in sns.kdplot to fill the area under the KDE curve, enhancing the visual appeal and making it easier to interpret. KDE plots aren't limited to univariate data, they can also visualize the joint distribution of two variables. This is known as a bivariate KDE plot. Use the following command to create one, sns.kdplot data equals tips, x equals total underscore bill, y equals tip. This code generates a contour plot showing the density of the data points across two dimensions. The resulting plot illustrates where data points are concentrated, giving insights into the relationship between the variables. Bivariate KDE plots are particularly useful in fields like finance and biology, where understanding the interaction between two variables is crucial. Kernel density estimate plots are not just for academic exercises, they have practical applications across various industries. In finance, KDE plots can help visualize the distribution of stock returns, aiding in risk assessment and portfolio optimization. In healthcare, they can reveal patterns in patient data, assisting in diagnosis and treatment plans. For example, by plotting the distribution of glucose levels in diabetic patients, healthcare professionals can identify abnormal patterns that require intervention. These plots enable you to see beyond the raw data, highlighting trends and patterns that can drive data-driven decision-making. By mastering KDE Plots, you equip yourself with a powerful tool for uncovering insights in complex datasets.
In conclusion, KDE Plots are a versatile and powerful tool in your data visualization arsenal. They provide a smooth, interpretable view of data distribution, revealing patterns and insights that other methods might miss. Whether you're working with univariate or bivariate data, customizing bandwidth, or overlaying with histograms, KDE Plots enhance your analytical capabilities. We encourage you to practice creating and interpreting these plots with your datasets, and explore further learning opportunities to deepen your understanding. Thank you for joining this tutorial on mastering KDE Plots with Seaborn.